Last week, I explained lots of indices, and throughout that last week, we were able to cover, I think, maybe 4 laws. So today now, last week I treated 0 law, whereby any number raised to the power of 0 is equal to 1. So now, let's move to negative index law. Negative index law. Negative index law. And this law says that when an alphabet or a number is raised to a negative index, the result is going to be the number. Say 1 all over the number raised to the power that you have. 1 all over the number raised to the power that you have. And this is what I mean. When you have a raised to power minus b, for example, this becomes 1 all over a raised to power b. So that is what we are talking about. And if you look at it very well, we are going to say, okay, let's take some examples. If I say 5 raised to power minus 2, 5 raised to power minus 2, what I'm telling you here is that 1 all over 5 raised to power 2. Do you get? And when we say 5 raised to power 2, we have 1 all over 25. That is your answer. Look at another one. 6 raised to power minus 3 becomes 1 all over 6 raised to power 3. That is 1 all over 6 raised to power 3 is 6 times 6, which is 36. Oh yeah, 36 times 6. Two, 1, 6. That is the answer to that. Sometimes I can as well have 10 raised to power minus 4. That gives me 1 all over 10 raised to power 4, which is 1 all over 10,000. So I guess this is it. That is negative index law. We also have another law which is called fractional index law. Fractional index law. Under this fractional index law, you have a number or an alphabet raised to a fraction, let's say 2 over 3, or let's say a over b. What you are going to have is this. You put your a in the brackets, and the next thing, when you put your a in the brackets, you put the n here. Let's say n all over m instead of using a all over b. So you put your n out, you put your m here. And that is how you are going to solve the problem concerning that. So, let's take a series of examples. Sometimes you might be given a question, and the question is going to look this way. 125 raised to power 3, 2 over 3. 125 raised to power 2 over 3. You have been given this. What you are going to do here is to say, write your square root sign, put your 125 inside that, put your 3 outside, put your 2 up. Now, what this actually means is that which number can you multiply 3 times? The number that you multiply 3 times, that will give you 125. That's what they're actually telling you here. And what does that mean? It means if I say 5 times 5, that is 25. 25 times another 5, that is 125. So my answer here is going to be 5 raised to power 2, and that is 25. So that is fractional index law. I think with this, let's take some examples, further examples, before I now move to some higher problems when it comes to indices. You see, indices is a very simple topic, but sometimes when you are not sound, you're not able to solve most of the problems that you will have. Okay. Look at this now. Times 15. $125 raised to power minus 2 over 3 times 15. This is the question that we want to solve. We want to solve this problem. How do we go about this? If we want to solve it, we already know that we have negative index law, right? Sometimes when you are being given a question under indices, what you just need to do is to look at the law that goes with each of the steps that you need to solve. If you look at this step now, you will notice that we needed fractional index law, and you are going to have this 1 all over. Is that also? And you are going to have 125 raised to power 2 over 3, then times 15. That one is there. If I multiply this thing together like this, or let me leave it this way, at the long run I'm going to have this 1 all over this, Abi, that is fractional index. Having 125 inside, then my 3 is here and my 2 is here, times this 15. I'm now going to have 1 all over 5 squared times 15. Is that also? So, at the long run, I'm going to have 1 all over 5 times 5, then times 3 times 5 up. Is that also? I'm just breaking things down for you. Then 1 times all of this, you have 3 times 5 upon 5 times 5. Looking at it, 5 cancel out here. You have 3 over 5 as your final answer. I decided to split everything like this because I want you to understand what is there. Questions can come anyway. Look at this now. Example 2. We have, let's say we have 125 raised to power minus 1 over 3. 125 raised to power minus 1 over 3 times, okay, let's say this. We have been doing the one of minus 6. So don't let us just stick to that. Raised to power 1 over 3. Then times, let's say we have 49 raised to the power of 1 over 2 times 10 raised to power, let's say we have 10 raised to power minus 1. This is what we have, and this is what we want to do. This is what we want to solve as a problem. So we have it this way, like the way we have been solving the other ones. You say this 125, you put your 3 here, times, you know you have 1 up, you can put the 1 there, but if you don't put it, you are still good to go because it does not have anything like minus. That's why you need to leave it that way. Then times, you have this, you put your 2 here, you put your 49 here. Actually, when something is raised to the power of half, it means square. But for you not to get confused, I need to just put it that way so that we will be following the same law that we have been following. This one is having minus. Then you have 1 over 10. Having 1 over 10, the next thing is cube root of 125. That is 5 raised to power 1. Abi? Multiplied by square root of 49. That is 7 times then 1 over 10. At the long run, you are going to have 5 times 7. That is 35. Times 1. That is 35 over 10. Which is 3 whole number 5 over 10. At long run, you have 3 whole number 1 over 2 as your final answer. I hope this is making sense. So, let's assume we have another question that looks like evaluate 9 is for 0. This is what you have as a question. It is very cheap. How will you go about this? If you look at it very well, you have 1 over 16 already, and you have minus 3 over 4. How am I now going to go about this? You don't need to stress yourself. What you are just going to have is this. 16 raised to power minus 1 raised to power minus 3 over 4 times 5 times 1. Because any number raised to the power of 0 is 1. So, we will now have this 16 raised to power 3 over 4. Because minus 1 times minus this gives us plus this. Times 5 plus, it's plus that is there now, not times. Plus 5. So, at the long run, applying the fractional index law, you are going to have this. Your 4 is going to stay here. Your 16 will be here. And then your 3 is going to be here. Plus the 5. So, you are now going to have, which number am I going to multiply 4 times to give me 16? That one is 2. Raised to power 3. Then plus 5. 2 raised to power 3 is 2 times 2 times 2. That one is 8. Plus 5. That is 13. I think I'm making sense. So our answer is 13. Our answer is 13. Divided by, I now have 64 divided by 125. Raised to power minus 2 over 3. This is what I have as the question. Yes. How do I go about this? How do I go about this? That is the next thing that we need to think of. If you look at this thing very well, the original question is going to look like this. 2 divided by 64 over 125, Abi, raised to power minus 2 over 3, Abi. Another one is 2 divided by 1 all over, Abi, 64 over 125, raised to power 2 over 3. Am I still making sense? See, look at this. So you are going to have your 2 divided by this thing back. 2 divided by 1 over 64 over 125. This is what you are going to have here. Over 2 over 3. Abi? So at the long run, you are going to have 2 divided by. This is going to be 1 over 64 times 125. Abi? Over 1. According to the rule of divisibility. So at the long run, you are going to have 2 divided by. Don't forget that we have something here, which is what? 2 over 3. At the long run, you are going to have, you put your listing here. So you have 125 all over 64. Then you put your 2 here, put your 3 here. Am I still making sense there? Yes. This is 2 divided by 5 over 4 square, which is 2 divided by 25 over 4. So 16, I mean. So this is now going to become 2 divided by 25 divided by 16, isn't it? We now have 2 divided by 25 times 16 over 1, and this becomes 32 over 25. How many 25 can we find in 32? That should be 1. You mean that's 7 over 25. This is the final answer. Do you understand now? Do you understand? Okay. Let's take a look at this question. 16 whole number 1 over 2 times 8 raised to the power minus 4 times 3 raised to the power minus 2 over 3 divided by 81 raised to the power minus 2 over 3. So the very first thing you need to do here is that you look at it. This one now, 2 raised to the power 4 is going to give us 16, right? Times 1 over 2 up there. Then 2 raised to the power 3 times minus 4. Then 3 raised to the power minus 2 over 3 divided by 3 raised to the power 4 here, then minus 2 over 3. So you are now going to have, this becomes 4 times half becomes 2. 4 times half becomes 2. This one is 2 raised to the power minus 12. This one is 3 raised to the power minus 2 over 3. Then this one is 3 raised to the power minus 8 over 3. I guess we are still making sense there. So let's group them. According to the law of indices, this is 2, this is 2. We are going to have 2 raised to the power 2 plus minus 12 times, we are going to have 3 raised to the power minus 2 over 3 minus 8 over 3. That is what we are going to have if we use the law of indices. So we are now going to have 2 raised to the power 2 minus 12. Then here, this fraction, they have the same basis. So we can say 3 raised to the power minus 2, minus turns to plus 8 over 3. So at the long run, we are going to have 2 raised to the power minus 10 times, this one now is going to be 3 raised to the power 6 over 3. So our solution here is now going to be 2 raised to the power minus 10 times 3 squared. Is that also? Yes. Yes, according to this law of indices again, what we are going to have here, you have 2 raised to the power minus 10 times 3 squared already. So what we are going to have here is 1 over 2 raised to the power 10, then times 9. Abi? Our answer is going to be 9 all over 2 raised to the power 10. So what is 2 raised to the power 10? That one is going to be 9 all over 1024. Answer. I said it last week that you need to learn the laws before we start giving ourselves something that is going to look somehow. Majorly, in your schools, you must attend further mathematics class. whether you are in science, commercial, or arts, so that your knowledge about mathematics is going to be somehow sound. If you are not attending those classes, you might find it difficult to comprehend with some of the things we are doing here now. So if you are in SS3, that means you still need this topic because it's coming out in your examination. I think I can move on. Are you done with that? Okay, let's pick another question. So, I'm going to solve this last problem. After the last problem, I will know, take questions. Okay, look at this now. Look at this. Whenever you see a question, you need to look at the approach that you need to use in solving those problems. If you don't know any approach, that means you might hang somewhere, you might not be able to solve the question. If you look at this, we have division law, Abi. We have the addition law, which is multiplication here. We have the fractional index. We are combining series of laws together now in order to arrive at a particular answer. If you look at it very well, you are going to see that this 9 that is here can easily be like this. 3 raised to power 2 times half. Multiplied by this 27 that is here can easily become 3 raised to power 3 times 2 over 3. Meanwhile, this 61 that we have, this 64 that we have here, a number that can multiply 4 times, 3 times to give us this one now. We are going to have this. Let me put it so that I can understand. 64, you put your 3 here, you put your 2 here. And this becomes a single 3 here because they are having the same basis. So what we are going to do here is to say you have 3 here. 2 times half is 1. Why your times change to plus? 3 times 2 over 3 is 2 because 3 here cancel out. Then you have 2. Everything divided by here is going to be 4 raised to power 2. So you are now left with 3 raised to power 3 divided by 4 raised to power 2, which actually becomes 27 over 16. So now you leave your answer this way. Or you proceed and say, how many 16 can we get in 27? How many 16 can we get in 27? That one is going to be. What is the answer? 1 whole number 11 over 16. So, final answer. So, thanks for today's class.